Today we continue with the analysis of the Earth's magnetism. This presentation has two main objectives. First, we will summarize the previous presentation. And then we will propose a possible origin for the net electrostatic charges on the planets, moons and other bodies of the solar system. In the previous presentation we had seen the four main anomalies related to geomagnetism. The first one mentioned was that it has been found that, although there is a magnetic axis, it is not aligned with the geographic axis. Furthermore, the magnetic axis is displaced with respect to the axis of rotation, so that both axes do not intersect at the center of the Earth. Further, constituting what is possibly the most striking anomaly of terrestrial magnetism, periodically the magnetic field reverses its north-south orientation. And, finally, this deviation from the axis of rotation does not remain constant, but suffers permanent drift, so that we can speak of traveling magnetic poles, with the additional characteristic that the displacements of the magnetic south pole are usually not symmetrical with those that suffers the magnetic north pole. But I also mentioned that the biggest anomaly should be considered the very existence of the Earth's magnetic field. In that presentation I introduced the possibility that the Earth's magnetic field is not the result of phenomena that occur in the center of the Earth. The current explanation resorts to a gigantic dynamo through which significant amounts of electrical current circulate. Possibly the weakest part of this model is the origin of these electric currents, whose mere existence is, at least, difficult to justify. As an alternative, I mentioned that the magnetic field of our planet could originate as a consequence of a negative net planetary charge. In this case, the currents necessary to generate a magnetic field on a planetary scale would be obtained from the rotation of our planet on its axis. In this model, the Earth would behave like a gigantic rotating sphere charged electrostatically and generating, therefore, a magnetic field whose periodic inversion would be the result of the change of sign in the net electrostatic charge of our planet. But, for this model to be sustainable, it is necessary to explain what would be the origin of the net electric charge and what would be the reason for its change of sign periodically. That is precisely the main objective of this presentation. In reality, we will see that the one that is impossible is the reverse situation. We will see that the net charge of our planet is inevitable, as it is subjected to a powerful variable electrostatic field, whose origin is in the Sun itself. Let's start with a simple concept that becomes important to explain the origin of the spontaneous separation of electrical charges at the scale of the solar system. The escape velocity, with respect to a massive body, quantifies the necessary initial velocity that an object must have to leave such massive body. In the case of the Earth, we know that, for an object to overcome the gravitational forces of attraction of our planet, it must start its journey with a speed greater than 11 km per second. In this analysis we are assuming that there are no friction forces and that the only driving force is the one that gives it its initial velocity. In images we see that, if the object is thrown at a slower speed than indicated, it reaches a point of maximum distance, and then returns to the Earth's surface. The old expression "everything that goes up, has to come down" is based on this knowledge. But if the initial speed exceeds 11 km per second, the withdrawal is complete. We say, in short, that the Earth's escape velocity is 11 km per second. In the case of the Sun, surrounded by what is known as the Sun's corona, the escape velocity is approximately 600 km per second, close to 380 miles per second. For the purposes of our analysis, we are going to focus especially on the behavior of the particles that make up the solar corona. According to Wikipedia, a corona is an aura of plasma that surrounds the Sun and other stars. The Sun's corona is much hotter, by a factor from 150 to 450, than the visible surface of the Sun. The photosphere's average temperature is around 5800 Kelvin compared to the corona's 1 to 3 million Kelvin. The corona behaves like a gas which is very hot but very light at the same time. the pressure in the corona is usually only 0.1 to 0.6 Pascal in active regions, while on the Earth the atmospheric pressure is about 100 kilopascals, approximately a million times higher than on the solar surface. However, it is not properly a gas, because it is made of charged particles, basically protons and electrons, moving at different velocities. Supposing that they have the same kinetic energy on average, for the equipartition theorem, electrons have a mass roughly 1,800 times smaller than protons, therefore they acquire more velocity. Therefore, if we summarize the previous slide, we find that in the solar corona we have a plasma which behaves similarly to a gas formed by protons and electrons at about 2 million degrees Kelvin. And, if we add to this that the mass of electrons is about 1,800 times less than that of protons, it turns out that the speeds at which both particles move are remarkably different. Therefore, it is interesting to compare the possibility of escape from the solar gravitational field for protons and electrons. If, as a first approximation, we use the Maxwell-Boltzmann velocity distribution law, it follows that protons have a velocity distribution like the ones shown in the figure. If, in that figure, we add a line that indicates the gravitational escape velocity of the Sun, we can see that practically, in the solar corona, there are no protons with sufficient speed to escape the gravitational pull of the Sun. But the same analysis done for electrons shows that the great majority of them have enough speed to escape from solar gravity. Going back to a previous slide. Each time an electron escapes the solar attraction, a positive charge accumulates in the vicinity of the Sun. This situation inevitably leads to a scenario in which, due to cumulative losses of electrons, the Sun begins to acquire a more and more positive charge, until the electrostatic field adds a barrier powerful enough to prevent the leakage of more electrons, reaching an equilibrium situation in which the central positive charge remains constant, as long as the temperature of the Sun's corona remains constant. However, we know that the temperature of the solar corona is highly variable, so it is to be expected that the central charge, although it must always be positive, must undergo notable variations with time. This is exactly the subject of the next presentation. All of the above leads us to the fact that the Earth, as well as other planets in the solar system, is subjected to the influence of a powerful electrostatic field. This field, in turn, results in the Earth, seeking its potential balance, absorbing positive or negative charges, depending on their availability and the corresponding equilibrium potential. In short, as the temperature of the solar corona fluctuates, so will the net charge of the Earth, with respect to its environment. And, as long as the Earth does not reach its electrostatic equilibrium, it will present net charges, positive or negative, with respect to the potential set from the center of the solar system. The previous analysis was made considering the Sun as an independent entity. However, the Sun is part of a galaxy, in which the aforementioned electrostatic phenomena can be even more intense, so fluctuations in the temperature of the solar corona can lead the Sun itself to have net, negative, or positive charges with respect to the electrostatic potential of the superstructure that represents the Milky Way. So, using this electrostatic model, in the next presentation we will analyze the cause of the periodic reversal of the solar magnetic field.